Speaker is Yair Horesh from Intuit AI. Please.
Hi, good afternoon. As said, I'm a data scientist at Intuit AI. My talk will be on AI and fairness. And this is the longer title, which is based on a study we done last year. And I must say, on a personal note, I'm honored to appear after Sarit Kraus. My first AI course was at 1998, and she was the lecturer. So it's cool. So what I'm going to do is to try to convince you that AI is biased. I will then try to convince you that there are no easy solutions to de-bias AI. And after that, I will try to convince you that I have a good solution for that. So this is my plan. So let's start with some background and terminology. Let's define some terms. So discrimination is making a distinction on a person based on the group she or he is perceived to belong to. Protected class refers to a group of people that are legally protected. And here you have a partial list of protected classes. Few more terms. Disparate impact and disparate treatments are both discriminatory practices. The difference between the two is that disparate impact usually is done unintentionally. Disparate treatment is intentional. The last term I want to cover is affirmative action, in Hebrew, אפליה מתקנת, policies that support members of a disadvantaged group. So can AI be biased? My answer is can birds fly? And this is not a rhetorical answer, it's an analog. So as in the nature of birds to fly, I want to argue it is in the nature of AI to generalize. And once you generalize, you paint things in broad brush. So by definition, at least machine learning is biased. We people, do you think that people are biased? Yes? Okay, we are very biased. We are biased by evolution. Our brain is wired to be biased. We use what is called mental shortcuts. The mental shortcuts are heuristics that help us all the time to evaluate our surrounding. It helps us do quick decisions and to cope with the burden of never-ending information flow, which is not only now, but even back then was overwhelming. So our intuition tells us that machines are bias-free because they use statistics, and everybody knows that if you use numbers and facts, it must be okay, right? You can't get wrong if you use numbers and facts. So this is one intuition that you hear a lot. An alternative answer is that, well, maybe being biased is something that is hard to do. Maybe you need to be smart in order to be biased. So maybe if you will find biased labels and you build a classifier, maybe you can and look at it as a task. Maybe machines can be biased, but it's not something that they do by default, right? And as you can see, back less than 10 years ago, there wasn't much talk about fairness in AI, and nowadays there are conferences and many papers each year. And there is this term FAT AI. FAT AI is fair, accountable, and transparent AI. Ethical AI, green AI, and I'm sure there are more to come. I want to give you a few examples of biased AI system. I will start with the most extreme one. Compass is a decision support system used in US courts. It's very important to me to say it was created in goodwill. It was created to help judges give a standard risk score to defendants, and not having every judge at different times of the day give different scores to the same person. And the system goes like this. It's supposed to make a prediction, will you reoffend in 2 years? It fills 147 questions. The questions are pulled from your criminal record, and there is a questionnaire. The questions, as you can see here, are around your environment, and some of them are even moral questions. Is it okay to steal if you are hungry? Did your parents went to jail? Stuff like that. And as you can see in the table below, the system is twice as likely to fail predicting black defendants as risky than white. It is twice likely to give a low risk score to falsely give a low score to white defendants compared to black. And as you can see in the examples on the right, you can get away with almost everything if you answer the right question and you have the right background. The reason that we know it is because ProPublica took 7,000 records from a Florida county and checked 2 years ahead was the risk score justified or not. Here is an example from last week. There was a small Twitter storm. A guy discovered that Apple Card allows him 20 times more credit limit than his wife. Although they live together, they share the same bank account. And Apple's and Goldman Sachs' reaction was not denying. So this was last week. And every week, I think, we hear these kinds of news. Gender classifiers, a study from 2 years ago, underperform for black women compared to other types of population. And you may ask yourself, why is AI biased? And I want to give you, to suggest few explanations. So one is that if you look at AI, there is a huge shift from what we call classical machine learning to advanced or deep machine learning. Even 10 years in the past, we used to have a lot more feature engineering. We preferred more simple models as a principle, and now you just feed the monster with your embedded vectors and let it runs on GPU for 3 days. Once we had very few parameters to tune and to ask them to converge. Now sometimes you have millions of parameters that you can control and you can't explain. The chart on the right tells the story. Neural networks outperform in terms of performance most of other common tools, and the trade-off is that they are much less explainable. Another reason AI is biased is that the data is biased. So if you ask 3 days ago, Google Translate about bakery and cars, well, women like to bake and men love cars, as you can see here. And a study from 2 years ago, if you look at this chart, you have occupations. The x-axis, the study looks on Word2Vec of occupations. The x-axis is how many women are occupying, the ratio of women occupying each of the profession, and the y-axis is the vector's bias or affiliation towards strong words that are strongly related to men or strongly related to women. And you can see this beautiful line which says that essentially the vectors encode gender very, very strongly. It's a very strong part of the encoding. Another maybe a bit technical reason why AI is biased is that many times we have this circle when we train a model, And then we apply a policy that prevents some class to challenge the policy. So I'll just give you an example. Let's say that I decide that a certain IP address should be denied. So we will never know if this IP address became benign, right? Because we always deny it. We'll never get enough statistics to see that we were wrong. And this exploration trade-off many times doesn't appear in AI models. Another very important reason why AI is biased is that removing protected variables intuitively seems the right way to mitigate discrimination. So if I have my data and I remove age, gender, maybe even zip code because I know it's related somehow, then surely my data is now okay. Surely I will not make any discrimination. But the problem is that proxies and surrogates of discriminating factors infiltrate to the data in many ways or by a combination of few of them. If you look at the Compass example, it's a great example when questions like, do you struggle to get minimum wage? Did you get into fights at school? Are proxies of neighborhood and proxies of race, right? And this is when you have a structured text. This is a great example for unstructured text, which is more complicated. There are reports that Amazon had to scrape an AI recruiting tool because it discriminated against women. The tool was designed just to find good Java developers, and I think that the inventors thought that words like front end and a lot of experience will be good words, and they will get a good score to filter the many CVs that Amazon gets. In practice, what the system did is downgraded CVs with the word women's. It downgraded particularly to women-only school. And you might say that, you might suggest that, okay, maybe the problem is that they didn't mask women, men, gender-related words, race-related words, but it also it also preferred words like executed and captured, which are the words that men use much more than women. So these are a very good example of proxies, right? And there are now AI systems that can identify the gender of the writer by judging what words they use. What do you think? The word I, more men or more women use? Men. Of course. Easy. This was an easy one. Another problem that we have is that performance measurements are essentially an averaging metric, right? Precision, recall, accuracy, they all just average many predictions. And if all data points have the same weight, in many cases, if the majority class is big enough, right, you will get a fairly good score. Even the minority class severely underperforms, right? So many times we should ask, what is is the precision the overall precision? Is it the precision of the majority class? And to be more accurate. Another problem that I think you will agree with me is that both data scientists and engineers don't have any awareness about ethics. Real estate dealers, accountants, physicians, lawyers, they all have to get a license. They all have to pass tests also about ethics. We don't. We just code, right? We don't bother with this nonsense. So we have no awareness. Of course, we are not accountable because if there's a problem, it's the model fault. It's not ours. And even worse than that, our managers always encourage us to improve accuracy. Right? I never heard the manager say, guys, I want to trade 5% accuracy for fairness or for something else, right? My final point on why AI is biased is that fairness, even in perfect goodwill, is very, very elusive. Fairness is subjective, is domain-specific, is context-specific, and thus it is impossible to find a general framework that does fairness. If you see on these policies, we can have an hour discussion on each of them. Are they fair or are they not fair? And what are the moral implications of each of them, right? Using an IP address to detect fraud. Surely it's not fair for the person that lives within this IP address and want to open an account, right? Surely it's also not fair to make a disservice to all the people that should be protected against fraud. There are no easy answers, and it's very, very domain specific. So here are a few general ways to mitigate bias. One is, of course, careful data collection. The second, which is a very nice trick, take your model and try to use your input data in order to predict some protected class. So see if you can predict gender using your data. And of course, we all hope that you will fail, right? So this is something that is used here and there. Of course, making the model explainable should help, although in very large scales, it's practically impossible. And there are two terms that I want to go over with you. Group fairness is the idea that we can force the same score distribution to two groups, for example, men and women. And I want to ask you, what do you think about group fairness? Is it always the right policy? So if I get a 40-60 ratio of men and women applying for a job, should I expect them to have the same score distribution? No? Well, I think the answer is no, because it might be that only very qualified women submit their CVs to this job, and less qualified men submit their CVs to the job. So using this apparently fair policy is disparate treatment for women, right? Another notion I want to go over is individual fairness. Individual fairness means that similar individuals should get similar scores. It sounds right. The problem is to find the right metric to evaluate similarity. So what is similar individuals? Is it some kind of Euclidean distance between the numbers of the vectors that represent them? Is it fair? I don't know. So it's a very hard problem. So here is what we suggest. Since fairness is so complicated and hard to formalize, let's do less. I don't offer you a solution that solves or mitigates fairness. What we can offer you is to build a model that is consistent with your notion of fairness, and do it so but using examples. And I'll give you an example. So once I have a data set, or even before I have a data set, I want to use a domain expert and ask him or her to sample pairs of data points. The data points pair should have two attributes. One attribute is that each pair member should differ in at least one value of a protected variable. So for example, if you see these two pairs, you can see that we have one male and one female in every pair. Of course, if I don't have the gender attribute, I can just pull many pairs, hoping that some of them will include one of each. And the second demand is that the two pair members should get the roughly same predictions according to my judgment. So for example, I chose the first and the third one because I think they are both not qualified for getting the next step. And I chose the second and the fourth because they're not identical, but they have a very, very similar background, and I think that they both should be accepted to the next step. It's very important 10 minutes, cool. It's very important to me to note that this idea is model agnostic and feature agnostic. Once I prepare these pairs, I don't care if you tokenize the data to words or diagrams or whatever and use embedding. I don't mind if you do feature extraction of some sort. I'm completely model and feature agnostic. So one simple thing that we can do with these pairs is just to count them. So what I suggest is using a paired consistency score. For classification is simply the ratio of pairs having their numbers assigned to the same class, which is practically saying that how much time the model agrees with me, right? Is the model consistent with my notion of fairness? In this example, obviously the answer is 0.5 because the model disagreed with me in one of the two pairs. For regression, it's pretty much the same. It's the average normalized gap between the score of the two members. It's very straightforward to find the gap. So now we have a way to monitor how consistent is the model with our notion of fairness. But I think the cool thing is this: we can use PerConsistency to model, to regulate our model. And the idea that if you take a simple loss function, for example, mean squared error, you can add a component which includes a regulation factor, how much regulation is important to me, and the formula that I just show you. And adding this penalty will encourage the model to find solutions in the space of solutions that agree with my assertions, right? Okay?
How do you prevent the model to do overfitting? For this, you have a very few examples. You have a very huge model. How do you accommodate for the possibility that the model will just study these pairs and just say, I agree only on these pairs?
The loss function still have the main part. I still want to optimize. Well, of course, you can cause overfitting if you use too many pairs, right? And if it's too few, it will find solutions that still comply with your assertions, but are perfectly fine, right? Let's continue. Okay. And just a fun idea, you can also assign weights to the pairs, right? You can say that this pair is very important for me. And if you give an infinite score for a pair, it's practically to veto the model using a solution that involves having this pair intact, right? So we did a very, very short toy example experiment. We took the very common census income data set. It has more than 32,000 records. Age was our protected variable. Income was our target. We used two models, a decision tree and a logistic regression. We added our penalty to the loss functions of these two models. And I will say it very short. Basically, as expected, as the regularization weights goes higher, the ranking of the age, and we let the age be included in the data because we want because we didn't have a good proxy for age. So age serves also as its proxy, but as the regulation weights goes higher, higher is the ranking, worse is the ranking of age compared to other features. Same goes with the number of pairs that we use. Okay. And basically that's it. So to sum up, this idea is very simple. It is feature and model agnostic. It's very intuitive and easy to use to define fair by examples. You don't have to be a data scientist in order to define fairness using example. It has a very nice byproduct because by adding so many constraints, you narrow the variance the model. It is a preventive care type of model. It's quantifiable. You can get a score and you can monitor this score. And of course, the caveat is that it's labor intensive and of course subjective. We plan to have an open source contribution, and we want to embed it in large scale systems. You can read about it in this article that was accepted to ECML Data Science for Social Good workshop. And thank you very much.
Time for questions.
Have you tried to remove the data the labor-intensive part by just like having regulator on distance between male and female in general? Like if you have like, you say in one of the parameters is discriminating, just regularize for everybody. Like in average, you're thinking that they will have the same distribution, just make sure all male and females are on average close to each other as much as you can, like as a regulator.
I think this is the family of affirmative action, of book fairness and solutions. I think I can give you a very easy example, but it's actually not fair to try to model, to set equal opportunities to groups.
And as you said, humans are biased also, so yeah, it's still there.
Additional questions? Okay, so thank you, Yair, again.
Thank you.
And we'll be back in 10 minutes.